The moon may seem like a calm, glowing beacon in our night sky, but its true story is filled with cosmic collisions, shrinking crusts, hidden ice, and mysterious far sides that aren't so dark. Dive in to discover the moon's turbulent history, its surprising modern secrets, and why it's far more than just a pretty face up there. A rocky beginning. How the moon got its start. The moon's origin is as explosive as any Hollywood action movie, only with less CGI and more magma. Most scientists agree on the giant impact hypothesis. Around 100 million years after the formation of our solar system, a Mars-sized body named Theia collided with Earth, and the resulting debris coalesced to form our moon. This dramatic cosmic event left Earth and the moon gravitationally bound forever, playing a significant role in Earth's subsequent evolution. The collision not only formed the moon, but also imparted enough angular momentum to stabilize Earth's axial tilt, which is why we experience seasons today. This stability is crucial. Without the moon, Earth's axis would wobble chaotically, leading to extreme climatic shifts that might not have allowed life as we know it to flourish. The moon's presence has essentially served as a celestial regulator, making Earth's environment stable and suitable for life for billions of years. Far side versus dark side. It's not just a Pink Floyd album. Everyone loves a good dark side of the moon story, but the truth is more mundane and yet equally interesting. The far side of the moon, often misnamed the dark side, isn't perpetually dark at all. In fact, both sides of the moon experience roughly 2 weeks of daylight and 2 weeks of darkness. The misconception about a dark side persists because of the moon's synchronous rotation, caused by gravitational forces between Earth and the moon, which keeps the same face always facing us. Thanks to missions like Chang'e 4, humanity has been able to explore the far side for the first time. Chang'e 4 landed in the Aitken Basin, the largest and oldest impact crater on the moon, which could potentially offer insights into the moon's deeper geological history, providing unique samples that differ from those retrieved on previous near-side missions. Shrinking moon. The lunar Botox. If you thought the moon's appearance was unchanging, think again. It's slowly shrinking as its interior cools, creating cliffs in the crust called scarps. This ongoing contraction has led to moonquakes, similar to small-scale earthquakes, which are a reminder that the moon is more dynamic than it appears. These cliffs were discovered through imaging by NASA's Lunar Reconnaissance Orbiter, which shows evidence of recent tectonic activity. The scarps are relatively young, estimated to be less than 1 billion years old, quite recent in geological terms. These contractions have caused the crust to crack and thrust upward, creating features that suggest the moon is still very much geologically alive. This ongoing shrinkage is expected to continue, giving scientists an opportunity to understand the internal dynamics of other rocky planets as well. Lunar cataclysms. The late heavy bombardment. Think of the moon's early history as a poorly timed meteor shower, one that lasted hundreds of millions of years. Around 4 to 3.85 billion years ago, the moon underwent an intense period of impacts, leaving behind massive basins, many of which are visible today as dark patches known as Maria. This epoch, known as the late heavy bombardment, is significant because it also affected all the planets in the inner solar system, including Earth. These impact events brought water and other key ingredients for life to the planets, and the moon's geological history serves as a record of that period. The basins filled with lava, creating the Maria we see today. Since Earth's surface is constantly reshaped by plate tectonics and erosion, the moon's largely unchanged surface provides a window into this tumultuous time in solar system history. The colorful truth. The moon isn't bright white. Surprise, surprise. The moon isn't actually a glowing white sphere. Despite what we see in the night sky, the moon's real color is more like a dull asphalt gray. Its brightness is an illusion created by sunlight reflecting off its surface in the dark background of space. The moon's surface is covered in a layer of dust and rock fragments known as regolith, which is primarily made up of silicate minerals. These minerals have a low albedo, meaning they don't reflect a lot of light, hence the moon's true grayish hue. The dark patches visible on the moon, called Maria, are ancient volcanic plains that contain iron-rich basalt, making them appear darker than the surrounding areas. The moon's true color changes simply depending on its position in the sky and atmospheric conditions, but overall, it is far from the pristine white often depicted. Major lunar standstill of 2024 to 2025. The dance on the horizon. Every 18.6 years, the moon gives us an encore performance called the Major Lunar Standstill, during which its rising and setting positions on the horizon reach their most extreme points. This rare astronomical event has been observed for centuries and is considered significant for tracking the lunar cycle. The current standstill, which began in 2024 and will last until 2025, provides a unique opportunity to observe the moon at its farthest points north and south of the celestial equator. During this event, the moon rises higher in the sky during summer months and dips lower during winter months than usual. This phenomenon makes moonrises and moonsets appear at more extreme points on the horizon, similar to how the sun appears during solstices, and gives us a reminder of the complex dance between Earth and its satellite. Ice, maybe. Water ice on the moon. Water ice exists on the moon, mostly in permanently shadowed craters near its poles, where sunlight never reaches and temperatures can drop to a bone-chilling -247 degrees Celsius, -413 degrees Fahrenheit. The Lunar Reconnaissance Orbiter and India's Chandrayaan-1 first detected traces of water ice, and later, NASA's Lunar mission confirmed it by crashing into a polar crater in 2009. This water is trapped in tiny pockets of the regolith and could be a crucial resource for future lunar missions. It can be split into hydrogen and oxygen essential components for rocket fuel or used for drinking and breathing for astronauts, turning the moon into a potential supply depot for deeper space missions. Imagine using moon-derived hydrogen to fuel rockets for Mars missions. The moon might just become humanity's gas station in the sky. Failed moonshots and Artemis' hopeful return. Humans haven't set foot on the moon since 1972, following the Apollo 17 mission. Several plans to return have failed due to budget cuts and changing political priorities, such as President George H.W. Bush's Space Exploration Initiative in 1989 and the Constellation program under George W. Bush in the early 2000s. However, NASA's Artemis program aims to finally bring humans back by 2025. The Artemis program, named after the twin sister of Apollo, seeks not just to return to the lunar surface, but also to establish a sustainable presence. Artemis 1, an uncrewed mission, successfully tested new technologies, and Artemis 2 will follow with a crewed mission around the moon. Artemis 3 is planned for a landing, marking the first step towards the long-term goal of using the moon as a springboard for human exploration of Mars. Lunar farming, growing green on gray soil. The Chang'e 4 mission is also experimenting with growing plants in lunar soil, which would be an essential step toward future moon bases. Lunar regolith, although not very fertile, contains basic minerals that plants need, like iron, magnesium, and calcium, but lacks organic materials. To overcome these challenges, scientists are using nutrient-rich water and experimenting with genetically modified plants that could thrive in harsher environments. The idea is to make future lunar bases self-sufficient by growing their own food, thus reducing the need for supply missions from Earth. This kind of farming might one day be the key to longer-term space missions and even settlements on Mars. If successful, astronauts on the moon could have fresh vegetables grown just a few meters from their living quarters, a huge improvement over freeze-dried packets. The moon and the evolution of life on Earth. Lastly, the moon serves as a time capsule that has preserved the story of Earth and the wider solar system. Since it has no atmosphere, liquid water, or tectonic activity, it provides an untouched geological record. The moon's surface is like a museum of solar system history, with impact craters that have remained virtually unchanged for billions of years. Scientists can analyze these features to learn more about the conditions that existed in the early solar system. Moreover, studying lunar meteorites, pieces of Earth that have found their way to the moon, allows researchers to understand what Earth might have been like during its formative years. The moon's ability to preserve such ancient records makes it invaluable for answering questions about how our planet became habitable and how life started. It is a crucial piece of the puzzle in understanding not just our history, but the story of all rocky planets. Thanks for exploring the moon's dark history and fascinating facts with us. If you enjoyed this journey into the mysteries of our cosmic neighbor, don't forget to hit that like button and make sure to subscribe and ring the notification bell so you never miss an update. Thanks for watching, and see you next time.